My name is Nur Kaisarah binti Abdul Rahim.
Hi, my name is Ayu Hajratul Putri binti Muhammad Maturidi.
Konnichiwa, my name is Nur Farahani binti Azhar Hadi.
And my name is Nur Adriana Lahlia binti Muhammad Zaidi, and we are from Ibdp College Tunku Kursia with our project WASTE2WATT.
The Earth is constantly bathed in sunlight, yet half of it falls into darkness each day. For centuries, humanity has relied on the sun as a source of energy. Today, solar panels convert sunlight into electricity for our homes, schools, and cities. However, the efficiency drops when the thick clouds block the sun. At the same time, large amounts of food waste are discarded daily. In our institution, onion skins are among the most common waste produced. So we ask, what if waste could become power? This idea led to WASTE2WATT, a solar panel system. So, what is WASTE2WATT solar panel? WASTE2WATT solar panel is a product that reusing waste material, specifically onion skin, to create eco-friendly and cost-effective solar system to produce energy.
So let's move on to the mechanism, or basically how our products actually works. So the first one is light absorption, which is when sunlight hits the natural dye molecule extracted from the onions, the molecule will absorb the photons from the sunlight. So next, the absorbed light will give energy to the electron in the dye, and then the electron will move to a higher energy states and becoming excited electron. Next, the excited electron can move into a semiconductor layer, and then now the electron can move to an external circuit, and this flow of electron is the electric current. Last one is electricity generation. So basically, the electrons will travel through a wire and power devices, and then they will return back to the dye molecule through an electrolyte. So this process will happens in a cycle when the light continues shining. There are three aspects under the chemistry subject, where the first one is anthocyanins and natural dye. So the pigments that is extracted from the food waste, it has conjugated double bonds where it's allow the absorption of the visible light. And the second one is adsorption. Adsorption is a process where the dye will stick to the surface of the semiconductor. And the last one is redox reaction, where the chemical solution that is used, it acts as a shuttle that gives electrons back to the dye because it has been excited by the light. Next, let's move on to the physics concept involved in our product. So the first one is the photoelectric effect. So it basically explains how photons strike the dye and knock the electrons loose. The next one is quantum yield, which is the efficiency of the electron injection, meaning it tells us how many photons actually results in a traveling electron. So the last one is the internal resistance, which discusses the physics of Ohm's law in our product.
So next, we're going to talk about the biology mechanism, which is first biomimicry, and another one is food waste valorization. So what is biomimicry? Biomimicry is basically just like its name. It involves biology and also mimicking. So in this process, we're going to mimic the photosynthesis process, which is our food waste dyes will absorb sunlight to turn it into electricity. And next, we're going to talk about the food waste valorization. So instead of dumping this food waste into the landfill and turn it into methane, we want to use it as one of the functional electric components.
Let's compare both silicon solar panel and also food waste solar panel. So in the first aspect, which is cost, the silicon solar panel is more expensive to manufacture, while the food waste solar panel, it is more low cost because the dyes comes directly from the food waste. And next, the performance in cloudy weather, the silicon solar panel, the efficiency drops more in low light, while the food waste solar panel, it can still work relatively well in low or diffuse light. Third one is the environmental impact, where the manufacturing of the silicon solar panels, it requires high energy and chemicals, while the food waste solar panel, it is more eco-friendly and use biodegradable materials. And lastly, for the power output, the silicon solar panel can power homes and large devices, while the food waste solar panel, it is more suitable mainly for small electronics or experiments.
Now, I will explain the strength of our product, which is the Aureus solar panel that we improve by using onion skins instead of turmeric skins as a light-absorbing material. The first one is low cost. One major advantage of our product is that it has a low production cost. Onion skins are a food waste material that is widely available, especially from households and restaurants. Because this material is actually discarded, it can be obtained at little to no cost, which makes the solar panel more affordable to produce. Second, environmental friendly. Our product is also environmentally friendly. By using onion skins, we are recycling organic waste that would normally be thrown away. This helps reduce food waste while also turning it into a useful renewable energy technology. The third one is we use renewable energy. Another strength is that this solar panel uses renewable energy from sunlight. Sunlight is a clean and unlimited energy source, which means the system can generate electricity without relying on fossil fuels or combustion such as coal or oil. The fourth one, we minimize carbon emissions to the atmosphere. Our product helps minimize carbon emissions into the atmosphere since the solar panel produces electricity from sunlight rather than burning fossil fuels. It can reduce carbon dioxide release, which helps combat climate change. In summary, our Aureus solar panel using onion skins is cost-effective, environmentally sustainable, powered by renewable energy, and helps reduce carbon emissions, making it a promising innovation for greener energy production.
However, everything have its limitation, and our project have its own limitation, which is first, it is still in research, and second, it is low instability, and lastly, it is environmental sensitivity.
For our WASTE2WATT solar panel, there are several areas for improvement. First, the technology is still in the research stage, so pilot testing and phase implementation are necessary. Small-scale prototypes and controlled field trials will help evaluate its real-world efficiency. Second, adopting a modular design can make the system easier to maintain and repair. By designing components as modular units and training local technicians, maintenance can become more efficient and accessible.